Yes, good morning, class.
Good morning.
How are you been?
I'm fine.
I'm also okay. Today, our lesson, this beautiful morning. Class rep, I didn't get the assignment last time, the one I gave you. Meaning, I need to, the follow-up activity which I've given, you need to make sure that it's on my desk early enough for me to look at it and assess. Let's see who is not there today. Class rep is there, who is not there today. Where is Kevin Watch? Maurice Onyamo?
Present.
Where is Kipto Mary? Present. Where is Francisca? Present. And James, ameenda wapi? Ametoka kidogo. Hope is around. Yes. It's very good for somebody to attend classes, or if he's not around, to make sure that he has communicated, we know the whereabouts. We know where the student is. That's good. Today, after we have learned the topic of hyperbolics, we had started with the trigonometry. Now we were under hyperbolics, where last time we discussed about the hyperbolic equations. I think we understood well about the hyperbolic equations. Today we are trying to relate the two between the trigonometric functions and the hyperbolic functions. That's our today's lesson. Now I can write it here, is the relationship between trigonometric functions and hyperbolic functions. What are some of the learning outcomes which we need to, by the end of this lesson, we get the learning. The learning outcomes at the end of this lesson include, by the end of this session, the student should, one, what the student should know is number one, what the trainee should know, the relationship, show the relationship between trigonometric functions and hyperbolic functions using complex numbers. Number two, should solve problems involving these relationships in, let's say, in engineering. Those are our two objectives which we want to try and achieve by the end of this session. Now, before we go to the topic of today, or before we go to the session of today, we must get a recap of what we have done under the trigonometry and hyperbolic functions. We will start with trigonometry, where we must know the identities or functions, basic functions of trigonometry. This is very important for us to relate the two trigonometric functions and hyperbolic functions. Meaning we must understand the trigonometric functions, then we must understand the hyperbolic functions because we have done them previously. What are some of the trigonometric functions? We have sine. You can have sine theta,
we have cos theta, we have also tan theta. These we usually call them the basic trigonometric what? Functions. Any other function other than this, it's a derived function because it comes from the basic functions. Also, when we go to hyperbolic, we also have some basic hyperbolic what? Functions. We discussed them. What are some of the functions? We have cos theta. Another?
Sin.
We have sine.
Sin.
And also we have tangent. How do you pronounce this one? How do you pronounce? This is tangent. Is it
Tangent.
tangent? It is tangent theta.
Yes.
Okay. Now those are also some of the basic hyperbolic what? Functions. Those are some of the basic hyperbolic functions. That is also very key for us to understand the two. Now we want to try. James, where are you coming from?
Sorry.
Don't be usually late to this class. This is a very important class because all your engineering concepts, they rely on the mathematical concepts. Now it's very important for us to usually take very important interest on the mathematics in collaboration to the engineering. Now we were at the basic functions of trigonometry and what? And hyperbolic. Now, after we have known the basic functions of hyperbolic and the trigonometric functions, then now what we want to do, it is to find the link. It is the relationship, the link between the two functions. How do we come from the sine to the sine, or from the cos to, and from the cosine to the cos? How do we come up to get that if you have a sine theta, then you have been told, convert this sine theta into an hyperbolic equivalent? How do we go about that? Also, what we need to discuss, or what we need to know, is the Euler formulas. Why you taught the Euler formulas in your algebra? The Euler formula in the first semester of the first year, because that's where the Euler formula is discussed. Do you remember the Euler formula? Euler formula is where the cosine is being transformed into their equivalent exponentials. Like now, for example, trigonometric functions, those ones we have known there. Now we can start writing. We have some small notes for us to have some content before we continue forward. We say that the trigonometric functions in terms of exponential functions, the trigonometric function written in terms of exponential functions, like now we can have sine of x can be written as exponential ix, that is now the Euler formula, and also cosine of x can be written as exponential ix plus exponential. Make sure you note this. These two Euler formulas are very key. And also, this now the first point. The second point you should note is the hyperbolic functions. The hyperbolic functions. How do you get the hyperbolic function in terms of exponential representation? You can have, like now, I think we learned sin x equals to, we learned about sin x equals to, who can remember that? Who can remember that? Sin x equals to, you can refer to where we learned that. X exponential?
X.
X exponential x minus exponential next to x over what? Over 2. That's very important. And also, what about the cosh? Cosh of x is now exponential. Exponential x plus is negative x of also negative over 2. These are now the two very important expressions which I want to help us to try and link the two hyperbolic functions and trigonometric functions. Now you can be given us, if you want to do the linking or the relationship, you can have here a relationship. How do you now relate? This one was like the basic concept. These are the basic concepts. Now we are moving to relationship, which can be done via substitution. Via substitution. The relationship can be obtained via substitution. Now, how do we go? Okay, the relationship is via substitution. Now, for example, let's look at example 1. You can be told, obtain the hyperbolic, you can write this one as an example. Example 1. Obtain the hyperbolic equivalent of cos x. Obtain hyperbolic equivalent of cos what? X. What do we do about this? The number 1 under the solution, what you need to note is that you need to come here and have the Euler formula of the cos what? Cos x. That's what we need to have. Meaning the first step is you to remember the exponential functions or exponential expressions of either the trigonometric or the hyperbolic what? Function given. Now for that case, like now, you have been told cos x. Now you come here and have the Euler formula of cos x is exponential ix plus exponential negative ix over what? Over 2. If you have obtained this is the exponential expression of cos x, you will go to the hyperbolic section to look at which expression almost relates to this one. You will go to the hyperbolic expression here, you look at which expression almost relates to this one. And for you to look at, meaning you need to also have this one in your mind, the exponential functions of the hyperbolic functions. Now for this one, if you look at this, it almost relates to the cos of what? Cos of x. Meaning now for this one, cos of x, you come and write it here, it becomes exponential x plus exponential negative x over 2. These two relate. But now when you look at this, it has an I, imaginary, where for this one does not have what? The I. Now what you need to put is that you will transform this hyperbolic function you have brought in to be like the exponential function of the what? The trigonometric given. Meaning, what you want to do, this cosine, the place where there is x, you will multiply by the I, which is there in the other what? Equation. Now for that, it will be equals to exponential ix plus exponential negative I what? X over 2. Now this function is the same to what we have been given. Now, you will conclude and say, for given cos x, it will be equals to cos I what? X. Now, this is the relationship between a trigonometric equation and a what? Hyperbolic equation. Is there an equation? Is there an equation? Very simple. Very simple. I want someone to come and try to evaluate the one for sine what? Sine x. You can do that in your books. As also you look at. You can do that one in pairs or individually if you can. It's just follow the same procedure. Just use the basic concept of sine x, already we have been given. The basic concept of sine x is here. Then you look at what can we relate between the two. What can we relate between the two? Then we can from there conclude that sine x relates directly to a certain function of hyperbolic. Good, that's good. That's okay. Continue. I'm seeing you are doing okay. Anybody who can frontier to come and do for us? Who will come and do for us? Come and do for us. Good. You can clean there. Just clean that bit. Just clean that bit.
So we all get to understand that sine x exponential I x exponential I x over 2. Yeah. Then c x exponential x exponential x over 2. So this, when we relate these two, c I x give us sine of x. This is the relationship. Am I right?
Let me see. Clap for him. Who has a different answer? That is group 3. Group 3 has done that one. Who has a different answer to that? Well done. Let us see. Just do it below, then we compare. Just do it below there. We compare the answers.
So now sine of x over exponential ix exponential over 2I. I think this one that we wrote here. So now the sin x now the exponential minus exponential of x all over 2. So now the sin of ix now be exponential ix minus exponential that is ix all over 2. So the sign of x one shows the relationship because that one will cancel. Sin of x is equal to the sine of ix. It shows the relationship.
Good. Clap for him. That's a good attempt. Now from here, if we look at the first attempt which he did here, there's somewhere he made a mistake. And if you look at the Euler formula for sine x has two what? Two I. Make sure when you are writing the Euler formulas, you write accurately as given here. So you have copied this one in your books. Make sure you use the correct Euler formula, because it is the one which is going to help you derive this thing correctly, or get a relationship between trigonometry and hyperbolic correctly. Any question?
So sine has an I, but the first one.
The first one does not have an I. Yeah. Make sure you note that one correctly. Now this one is a direct from trigonometry to hyperbolic. Sometimes you can be given the other way around. You can be given hyperbolic to trigonometry. Let's also try that. So to try that, we try the hyperbolic one. Then yes, now let's look at my example here. You can be given example 2. Find the trigonometric equivalent of cos x. Find the trigonometric equivalent for cos x. Find the trigonometric equivalent for cos what? Cos x. Now for that case, if you come to the solution, we say the one you are given, write the exponential representation of that function. Meaning cos x, we learned it, equals to exponential x plus exponential negative x over 2. Now if you are given that, you will relate the expression which you have gotten here to an equivalent Euler formula in the trigonometric function. Which function almost looks the same to that? It is the cos of what? Cos of x. Meaning you come down here and say this relates, you can have that this relates to cos of x, which equals to exponential ix plus exponential I negative x over 2. You shall have like that. Now, this function relates to this function. This function relates to this function. Now, but they don't look the same. This one does not have an I. This one has a what? An I. It means then we must remove this what? This I. What you need to note, what is an I? I is what? It's the root of negative? Negative 1. We went further and say I squared equals to, you know those things. Those are the complex numbers of imaginary part. Now from there, what you need to have, if you have gotten the I here, for you to remove the I here, what happens? Because we have said I squared equals to negative what? Negative 1. It means if we multiply this function of x with an I, we have removed it in the expression. It means if we come here and say cos ix, it will be I dot I x plus, that is exponential, remember that, and also here it is exponential. We have plus exponential negative I dot I x over what? Over 2. Meaning this one will multiply by this one becomes a what? A negative. This one will be, you can say equals to exponential negative x plus exponential, because if there is a negative here, it will be what? Approximative. Over what? Over 2. That's what we have. But now, this, does it now look the same to this? This, does it look the same to this? Yes. Now, if it looks the same, then we conclude that cos of x equals to the cosine of I what? Ix. Meaning you have related a hyperbolic function to what? A trigonometric function. That's the relationship between hyperbolic function to a what? A trigonometric function. Meaning in this class, we have done the first bit of changing from trigonometric function to hyperbolic function, and then we have done from hyperbolic function to trigonometric function. Is there any question? Is there any question? Any question? Where you have not understood? Where you have not understood? Yes, if there is no question, then it is important for us to have some follow-up activities for us to go and do what? Practice. Make sure you know that practice is important, because in mathematics, practice makes what? Perfect. Some of the follow-up activities. Follow-up activities. Number 1, let's prove that a tan x equals to negative I tangent of what? Hyperbolic tangent of x. Then we have B. You can prove the sec x equals to the sec I what? Ix. This one, you are proving the trigonometric function to hyperbolic what? Function. Let's have one. You can have one of either you are proving now from hyperbolic function to trigonometric function. Now, like we can have, let's prove tan x, that is the hyperbolic tangent of x, equals to negative I, the tangent of what? Of x. Class rep, I think before Thursday, we have another class on Thursday. This work will be done either individually or in groups. Then you submit them to my desk. Let it not be late submission like the one you did last Thursday. That one did not bring a good picture. I think it's an easier way for you to go through. But if you don't get it well, you can check on this book of John Bart. We can help you go through from, I think, page 500 to 503. There's this chapter of the relationship between trigonometric function and hyperbolic function. It can help you go through and also get a good comprehension of this. Finally, what I need you to go through is what are we learned today? What are we learned today? Under the learning outcomes, we had to show the relationship between trigonometric function and hyperbolic function. That is the first objective. The second objective is solving some of the application problems on this. Then, now, you individually, have you achieved the learning outcome? What have you learned today? Somebody else, what have you learned today? As a student, have you understood our objective?
Yes.
Have you gotten the Euler formula of the two either trigonometric functions and also the exponential or the exponential expressions of hyperbolic what? Functions. I think from there, let's meet on Thursday. Thursday, make sure when they have done the assignment, during the follow-up activities, make sure you drop them at my desk. for me to see if you have understood well the objective of today. Thank you, and have a nice day.
You too.